as we move on in chapter 1, and our new lesson today, lesson 1.3, we have a new learning goal. Kind of a lot like our learning goals back in the last couple of days, except now we're going to use the operations of multiplication and division. So you're going to be solving one-step equation. That means there should be a step of work shown, one step of work shown in one variable. In other words, you're not going to complicate it with more than one variable, thank goodness, using multiplication or division. Well, the first thing we need to do is review some things. What is the inverse operation of multiplication? How do we undo multiplication? With division, yeah, with division. So we're going to, but I do have to put a little, it's not always that we have to undo multiplication with division. Sometimes our variable is being multiplied by a fraction. And when that's the case, anybody remember, what can happen sometimes when you're dividing by a fraction? So if I ask you to take, 4 and divide it by 1/2, that actually works pretty well. Anybody tell me what the answer is when you take 4 and divide it by 1/2? 2? So you're telling me, okay, remember when you divide, okay, so 10 divided by 5 is 2. So when you divide, you say then, and the answer is 2, 10 divided by 5, that says there's 2 5s in 10, right? Okay, so let's do this again. 4 divided by 1/2, you're telling me then if that's 2, there are only 2 1/2s in 4. There's 8 of them, aren't there? Yeah. So that one we can divide, and it kind of makes sense to us. But then sometimes it's not so pretty, and when you're trying to divide by that fraction, you're like, I have not a clue. If I say to you, how many 3/8 are in 7? 7 divided by 3/8, that one's a little more challenging, isn't it? So instead of dividing by 3/8, then we take another strategy, we multiply. We end up multiplying with multiplying. Okay? So, and how do we undo division? By multiplication. Okay. So we're going to use those inverse operations to help us out. But then we also have to remember some of the rules for when you're multiplying and dividing. When you're multiplying or dividing two numbers with the same sign, I mean a positive by a positive or a negative by a negative, the answer will always be what? Positive. It's always a positive result. Okay, so if both are positive or both are negative, they both have the same sign, you will always get a positive result. Well, what happens when there's different signs? There's one of each. The answer will always be negative? What do you think? When you're multiplying or dividing, one of them is positive, the other is negative, or vice versa, negative, positive. Will the result always be negative? Yeah, it will. Yeah, it is. I don't think you'll ever find out. Yeah, so when I stop and ask, then you start second-guessing yourself, don't you? Don't second-guess yourself. You know this stuff. Come on. When you multiply or divide with different signs, one of each, then your answer will always be negative. Okay. The product of any number and its reciprocal. What does product tell us we're going to be doing? Multiplying. So we have a multiplication problem. If you take a multiplication problem and you have a number and you're multiplying it by its reciprocal, maybe that's a word we need to define here. What is reciprocal? Or can you give me an example if you can't define it in words? Benton?
It's like a number's opposite, kind of.
Be careful. There is a different definition for opposite. So, in other words, if I say to you, what's the opposite of 3? What is the opposite of 3? Negative 3. Opposites are the ones that are the same distance from 0. So, negative 3 is the same distance as positive 3 from 0 on the number line. So we can't really use the term opposites, but I kind of think I know what you're thinking about, but we can't state it that way. So can you give me an example of a number and its reciprocal?
3 and 1/3.
There you go. 3 is the number, 1/3 is its reciprocal. So they're not opposites because they're not the same distance from 0, are they? One's a lot closer to 0 than the other one is. So not opposites, they're reciprocals. Well, what's their product then? 1. Every time you take a number times its reciprocal, you will get 1. Okay, there's only one number that doesn't have a reciprocal, and that is, what do you think? 0. Yeah, 0 doesn't have a reciprocal because anything times 0 is 0, and we need the product to be 1. So the product is always 1. So you cannot have a reciprocal of a number unless when you multiply those two together. So what's the reciprocal? You get 1. So what's the reciprocal of negative 1/4? 4. 4? Has to be negative 4. Because a negative times a negative is a positive, and we need a positive 1, not a negative 1. We need a positive 1. So if the number is negative, its reciprocal is negative. If a number is positive, its reciprocal is positive. Yeah. These are things we need to make sure we know and we use them properly. Okay? So we're going to use those, review rules in solving our equations now. Let's solve this first one here, where we have a c over an 8 equal to a negative 7. Just tell me what's happening, because in that equation, because first of all, our goal is to solve it, which means get the variable alone. So that means you need to focus in on the side the variable's on and see what's happening on that side. So what's happening on the side with c? C is what? Being divided by 8. Let's put that in our notes. Let's just have good notes. I'm not saying you gotta write that out when you're solving the problems, but let's have good notes. C is being divided by 8. So what should we do to undo that dividing by 8? Multiply. Yeah. Multiply both sides by 8. Now, trust me, I don't know why this happens, but oftentimes students, sometimes I don't know if they like the other number on the other side of the equal sign better or what, but they end up multiplying by the other side's number, the constant that the equation is set equal to. But that isn't, we need to get the variable alone. We need this to go away. So here's how we're going to show that. We're going to show 8 times c over 8 equals, going to do it to the other side also. Some of you are only showing sometimes like what's happening on one side. That's a problem. That's not keeping the equation balanced. That's like being on the teeter-totter at Jefferson School, and you and a friend that are equal weight are on there, and then all of a sudden we throw somebody on one end and not on the other. Are you guys balanced anymore? No. Are you going to be able to teeter-totter very well? No. Okay. So what happens here is these 8's cancel each other out, don't they? So now the c is by itself. A positive times a negative is a negative. Different signs, always a negative answer. 8 times 7 is 56. Now, I also noticed that you did not really, I was kind of lenient in the last couple days' homework. It said to check your answers. Okay, I'm not going to make you, especially on these really, like one-step equations, I'm not going to make you check your answers, paper and pencil, but let's do some mental math on this, okay? Let's put it in there and see if it checks. So when we put negative 56 back into the original equation, it goes in there for c, we have negative 56 divided by 8. What's a negative divided by a positive, first of all? Negative. And 56 divided by 8 is 7. So we end up with negative 7 on the left side. We have a negative 7 on the right side. It checks out, doesn't it? Okay. Anybody have any questions about that one? Okay. Next one, notice something that's a little bit different about this one is not only is x being divided by 3, but what's that negative sign out front doing? It's like a negative what? Means the fraction is negative, or also could mean that the fraction is being multiplied by negative 1. So there's really maybe even 2 operations going on here. But here's the deal. When you have a negative fraction, did you know that you can give the negative sign to either the numerator or the denominator? You get to decide, hey, numerator, you're going to have it, or hey, denominator, you're going to have it. So when the fraction is negative, give the numerator or the denominator the negative sign, but make it convenient for yourself, okay? Which And why can you do that? Because once we put that negative sign inside the fraction, let's say we decide to give it to the 3. Now we have x divided by negative 3. What's a positive divided by a negative? A negative. So that negative sign that was out front, it's up there. But we're going to give it in because we know that if one of them is negative and the other one is positive, that makes it a negative. So we're going to multiply both sides by negative 3. So basically what we're doing, let's rewrite this though. Let's say we're going to give that negative sign to the 3. Yeah, we're going to give it to the denominator this time because we want that x to be a positive x. Because when we solve for it, it has to be. And now we're going to multiply both sides by negative 3. So negative 3 times this side. Negative 3 times this side. That takes care of that negative sign out front. It takes care of that 3 for us. These will cancel out. X will be by itself. And a negative times a negative. Over there is a positive. 3 times 4 is 12, just like 4 times 3 is also. Okay. So our solution is x equals 12. So let's put that in. Remember, mental math check. Put that in for our x. We have 12 over 3, which is what? 12 divided by 3, 4. And then there's that negative sign in front of it. So now it's saying negative 4. So we have a negative 4 on the right. We have a negative 4 on the left. Checks out. Any questions? Okay, so I'm trying to work some of the kinds of problems that you would see in your, for some reason I kind of lost the rest of my notes here. Let's see if I can find them. They're not in there. That's interesting. There they are. Okay. Just an extra page stuck in there. Okay, let's go to the back side. Well, y is being what? What's going on? Multiplied by 4, yeah. Y is being multiplied by 4. So in other words, this is the thought process we will have when we look at the equation. So we write the equation down and we say, what's going on? I need that y alone. Well, it's being multiplied by 4. So what am I going to do? Divide both sides by 4. Okay? So I write the problem again, so I know how it's. I always want to know how did it start before I started messing with it. So I'm going to put negative 15 divided by 4 with a fraction bar. I'm going to put 4y divided by 4 with a fraction bar. This fraction bar means division. And then I'm going to, these 4's cancel out. We have y by itself now. Oh, but is 15 a multiple of 4? No. Well, what's a negative divided by a positive? Negative, okay. And since 4 does not go into 15 nicely, here's what algebra allows you to do, and actually kind of likes it this way because it typically makes it easier to do check problems. Just leave it as an improper fraction. But then if it can be simplified as an improper fraction, or in other words, if something goes into 15 that also goes into 4, we would simplify it. Is there anything that goes into 15 that also goes into 4 other than 1? Because dividing by 1 isn't going to get us anywhere. So we're going to say the answer to this is a negative 15 fourths. If you want to change it to a mixed number, you're not wrong. What would it be? Yeah, negative 3 and 3/4, right? It would be negative 3 and 3/4, also known as 1 in decimal form. Negative 3.75, yeah. Okay, so, because, let me show you why. You can do this in your notes if you want. If we are checking this one, what happens is we have this negative 15 equals 4y. When we put it in improper fraction form, here's what happens. We have positive 4. We can make that into a fraction. Do we have to have common denominators when we multiply fractions? No. We have to have something that divides out of the upstairs, that divides out of the downstairs to help us simplify it. And basically, if there's a factor that's the same in both, we cancel it out of there. So see how that leaving it in improper fraction form, now we can cancel those 4's, and we see that we have negative 15 equal to negative 15. Because of 1 downstairs, anything over 1, we can ditch the over 1 part. Because negative 15 divided by 1 is still going to be negative 15. So that's why typically in algebra it's a whole lot easier to leave it as an improper fraction. Makes it easier to check it and not have to use your calculator, especially. So any questions on that one? Okay, here's one of those I talked about. You know what? Sometimes it's makes sense to us to think about, well, I wonder how many are this or in that. But this is one of those that, you know what? Even though m is being multiplied by negative 2/3, what would we undo that with? What would we undo that with? How do you undo multiplying by negative 2/3? Typically, what would you do? You would divide by negative 2/3, right? So here's what a student would typically show me. Don't write this down. Don't copy me right now. Here's what they would typically do. They would show it like this, and then they would amazingly have the answer right here, because they're saying to me, I know how many 2/3 are in 6 without my calculator. Really? Anybody here happen to know how many 2/3 are in 6 without a calculator right now? Okay, so if that's what your work shows, what do I have to assume? I'm not saying you cheat when you use your calculator. I'm saying that you're being lazy. That's not. There's a difference between cheating and laziness, I believe. Some of us are not cheaters, but we're lazy. Some of us might be both. Some of us might be neither. But this would tell me, if this is the way it was, that you used your calculator. You let your calculator do the work for you. Okay, so we're going to instead of doing that, we're going to use the multiply by the reciprocal of negative 2/3. What is the reciprocal of negative 2/3? Negative 3 halves. Negative 3/2. How about 3 halves or 3 over 2? So negative 3 halves is the reciprocal. So we're going to take both sides times negative 3 halves. So negative 3 halves times 6. This is going to be one of those times it's going to be really handy to make that 6 into a fraction. How do we do that? Put a 1 under it. 6 over 1. Okay, well, what happens here? When you take a negative times a negative, you get a positive. When you take 3 halves times 2/3, you get. Remember, a number times its reciprocal will always give you 1. Okay, so what really ends up happening here is these negatives cancel each other out, these 3's cancel each other out, these 2's cancel each other out, and what we really have here is 1 times 1. And 1m is an m, isn't it? Okay, so now we have a negative times a positive on the other side. Waiting to hear what that would be, positive or negative? Negative, okay, and we have 2 options when we multiply fractions. 2 options. Multiply across the top and across the bottom first, simplify after. I don't like that option. Sometimes the numbers get really big and then I'm like, I don't know if this is simplifiable or not. So I like to simplify before I multiply. How about you? Anybody like that way? Yeah. So what we do is we say, oh, there's a 2 downstairs. 2 just happens to also be a factor of 6. So this 2 becomes a 1, this 6 becomes a 3. As long as we divide the same thing out downstairs and upstairs, all is well, right? So now 3 times 3 is 9. We have 1s left downstairs, so we can ignore them, and 3 times 3 is 9. So for all of you who sat there and said, I know how many 2/3 are in 6, it's 9, isn't it? 2/3 plus 2/3 is 1 and 1/3, plus another 2/3 is 2. How many 2's are there in 6? 3. So another and another, so we have 9 2/3 altogether in 6. brains start doing instead of, oh, I know how to use the fraction key on my calculator. I don't even, and by the way, don't ever ask me how to use your fraction key because you got a brand new calculator, you don't know how to use it. I'm going to be like, I'm not going to show you. I'm going to show you. I don't want you to know. That would be crazy. Okay, circle this answer. If we did a check problem for this one, this would be a little bit harder to do mental math checking. So it would be put the negative 9 in for the 2/3. So if I'm checking this one, I do negative 2/3. I actually am going to have to physically do it. And I see if I get, so negative times a negative is a positive. They cancel each other out. And 3 goes into itself once and into 9 3 times. 1's downstairs, good, I'm done. 2 times 3 is 6. I do get 6 and it checks out. Okay. So notice we're not practicing problems that are like, 4y equals 16. Divide both sides by 4. 16 divided by 4 is, we're not practicing problems like that. Those are no-brainers. At this point of our math careers, those should be no-brainers for us. We're practicing ones that, are possibly going to challenge you a little bit more. What if you have negative 5x over 6 equals negative 2/3? To make this into a one-step word problem, this could become a two-stepper, but to make it into a one-step, here's what we can do. Whenever we have a factor upstairs, hear me on this, I don't want you to think, make up a rule and say, you go next year to a math class and you say, well, Mrs. LeGrand said, this is a new rule. No, here's the rule. If you have a factor upstairs, so negative 5 is a factor upstairs, x is a factor upstairs. If you have a factor upstairs, it can be pulled out and become a factor outside the problem. So this x or this negative 5 could come out. Well, I don't want the negative 5 to. I want the x to. I'm going to rename this as negative 5/6 x. So the x can be pulled out. Now we're saying x is being multiplied by a negative 5/6. And that's going to make this easier to solve. Okay, go, solve it. Do it. Solve this problem. Show your work. What do you have to do to solve for x? No calculator. Or do you have the answer ready? Okay, share with class what they should get. What should they get? 4/5, he says. Okay, see if you do. See if you correct. He's the only one whose pencil isn't moving anymore, so find out. I like your answer ready. So the reciprocal of negative 5/6 is negative 6/5. That's what we need to multiply both sides by. So again, it's easier to simplify before you multiply. And for those of you who are saying, I don't get that part, then just do the multiplying. A negative times a negative is a positive. 6 times 2 is 12. 5 times 3 is 15. Now you can simplify it. They're both divisible by 3, right? What I used to simplify within the problem. So you can simplify before, you can simplify after. So do you have good fraction skills? That's going to be the challenge. No calculation, fraction key doing it. Anybody want to ask questions about this one? You can't follow what I did up there? Or? Anybody else get it to happen on their own? I'll have you look up here. Jump, 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 okay, withdraw. Okay, let's get our sheet of listed paper, get your headings on there, and we have about 8 minutes